G'day guys, hopefully this works okay. I'm just going to cover Factorizing Quadratics again briefly. So if you recall, when we factorize, we took something that was the sum or difference of things, say 4x squared plus 12x, and when we factorize, we wanted to get this into the product of two things. And when I mean product, I mean we want to turn this sum into multiplication. So what does that look like? What two things would multiply together to give this entire term? And we discussed that we have that shortcut where we look at the constants. What is the highest common factor of 4 and 12? Well, it's 4. And then we started to look at the variables. This is a nice simple one. There's only one variable, x, and we've got an x squared and an x. And what's the highest common factor of x squared and x? Well, x squared is x times itself, and x is obviously just x times 1. So the highest common factor would just be x itself. So that is a factor that can come out of both of those terms. So that would leave just x and 3. So we've taken our sum of two things and we've turned that into a product of two things. Product meaning multiplication. So how do we factorize something like, say, x squared plus 7x plus 6? Well, let's just take a step back and look at how we expanded terms. So let's take x plus 2, x plus 3, and expand that out. So x plus 2 in one bracket, x plus 3 in another bracket, x times x squared, x times 3, 3x, 2 times x, 2x, and 2 times 3 is 6. So those numbers, 2 and 3, they multiplied to give 6. And you can see here we have like terms, 3x and 2x. So we've got x squared plus 5x plus 6. So they've multiplied to 6, and those two numbers have added to 5. So they add to the number in front of x, and then multiply to give that constant. So can we reverse that process on x squared plus 7x plus 6? Well, we can. We want two numbers that multiply to 6 that add to 7. And don't worry if that takes you a wee bit of time to think of. That is the hardest part of factorizing quadratics, because once you've got those two numbers, 1 and 6, the rest is quite easy. So this would become x plus 1, x plus 6. And it doesn't matter which way around you write those brackets, because obviously multiplication order doesn't matter. 2 times 3 is the same as 3 times 2, so it doesn't matter which way around you put those brackets either. We'll do one more. Let's have a look at x squared plus x, and we'll go with minus 12. So we want two numbers that multiply to minus 12 but add to 1. Have a think about what that might be. Well, the numbers have to be quite close together because they're going to add to 1, and obviously going to be opposite signs because they're multiplying to give negative 12. So if we factorize that, we should have x plus a number, x minus a number. Now, the positive numbers obviously has to be bigger because they're adding to positive 1. 4 and negative 3 in brackets. So we've got x plus 4 in one bracket, x minus 3 in another. And you could expand and simplify that and you should get this. So you can actually do a bit of a self-check. So if you wanted, you can make some notes on that by pausing the video. Otherwise, pause the video on this page and why don't you give these quadratic factorization questions a go. I'm going to begin going through these. in a couple of seconds. Okay, now these are all of the form x squared plus some number x plus 6. So the first one, x squared plus 5x plus 6. How can we factorise that? Well, we want numbers that multiply to 6 but add to 5. What numbers could they be? I'm thinking 2 and 3. Therefore, one bracket is x plus 2, the other bracket x plus 3. Next question, x squared, take away 7x, take away 18. So we want numbers that multiply to that constant, negative 18, but add to negative 7, because that's how expansion works. Those numbers are going to add to that number on the x, but they're going to multiply to that constant term. So we obviously want two brackets. One number has to be positive and one has to be negative, because we've got a negative 18, and that's the only way you can multiply and get a negative number. And the bigger number, whatever the bigger factor of 18 is going to have to be negative, since we've got negative 7. So 9 and 2, so it has to be negative 9 and positive 2, because those are what make negative 7. A little quicker now. So as you can see, on x squared, this is question 3, x squared minus 5x plus 6. Same numbers as question 1, but different signs. So they're going to add to 6, multiply to 6, but add to negative 5. So we're going to have double brackets. Now, we can start being a wee bit cunning about this. They add to a negative. Well, that means that one of those numbers is going to have to be negative, but they multiply to positive 6. Well, if one number is negative and then multiply to positive 6, then both those numbers must be negative. I could just teach you like algorithmic and list factors and plug them in, but it's quite nice to actually analyze what's happening with those signs as well. So negative 2 and negative 3. Okay, question 4, x squared, take away 5x, take away 6. So they multiply to negative 6, but add to negative 5. This one usually gets people. Almost got me today. So x, we're going to have negative 6 plus positive 1, because those numbers times negative 6, and those numbers add to negative 5. Question 5, x squared, take away 4x plus 3. So we've got a negative in the middle, so both those brackets are probably going to be negative. Well, they are. And we've got a positive 3. So 3 and 1. Nice and easy. 3 is a prime. And you quickly check those factors. Next question, x squared, take away 2x, take away 3. Double bracket. We have negative 3 is what they multiply to, and they add to negative 2. So minus 3 plus 1. Here's a tricky one. X squared plus 2x minus 143. Double bracket for this one. Now, we've got a negative and we've got a positive, because they multiply to 143. We've got a positive 2, so the numbers can't be that far apart. Now, what are the factors of 143? Since this is a harder one, I might have to go through and list some of them. Well, we can't divide that by 2. Can we? 144 is 12 squared, so maybe we're looking for numbers around 12, and they're only going to be apart by 2. So is 11 times 13 143? And you will see that it is. So we have negative 11 and positive 13. If you want to list all the factors of 143, that's fine. It's early days. Okay, here's an interesting one. X squared plus 9x. Now, when you put this question in front of people after they've been expanding lots of quadratics, they forget about the common factor rule as well that they've probably learned beforehand. So obviously the common factor, just like the start question behind this piece of paper, is they both share a factor of x. So it's simply x plus 9. Or if you want to go a little bit further, x plus 0, x plus 9, since those numbers multiply to nothing, or to 0, sorry, and they add to 9, but we like to leave it like that. So there's factorization. Let me know in the comments how that went. Otherwise, I've just got a quick special case to finish the lesson off on. So, special cases. We want to factorize these things, okay? So 4t plus t squared minus 5. I'm doing two things here. I'm showing you that they might not always be values of x. They could be t or m or a or any variable really. Now we want to be able to factorize this. We can't use our process that easily here because they're not in the right order. We want to get this in the highest power to lowest power to constant. So t squared plus 4t, take away 5. Now that we've rearranged it into that order, we can now do our factorization. Multiply the negative 5, add to 4. T minus 5, sorry, plus 5, and t minus 1. You could give this one here a go. M squared plus 11m plus 28. Now we want to factorize this. Numbers that multiply to 28 but add to 11. 7 and 4, I believe. Awesome. And there's a special case. More videos to come. Cheers.